Good everyone. My name is Graphics. If you look at the front of your screen, you will see a question. And the question says three pipes of diameter 300 millimeter, 200 millimeter, and 400 millimeter, and length 450 meter, 255 meter, and 315 meter, respectively, are connected in series. The difference in water surface level in two tanks is 18 meter. Determine the rate of flow of water if the coefficient of friction are 0.0075, 0.0078, and 0.0072 respectively, considering minor losses also and neglecting minor losses. Now, this is what we have here. It says the pipe are in series, and this is a diagrammatical representation of what they are trying to make us understand. This is tank A and tank B, and the difference in liquid surface level is given as what? Capital letter H. Now, three pipes are used to connect the tank A to tank B, and these pipes are in series, right? So there is a general formula that you use to connect the pipes in series to two tanks. And the general formula is telling us that the difference in the liquid surface level, it's capital letter H, equals to the head loss at the entrance, we use H sub I, plus the head loss due to friction in pipe 1, that is HF sub 1. And we have the head loss at contraction, that is H sub C, the head loss due to friction in pipe 2, we'll call it HF sub 2. We have the head loss due to enlargement, and finally we have the head loss due to friction in pipe 3, right? So this is a general formula that we'll focus on as we move along. Now you need to understand what the statement means. This is a bigger tank, right? At tank A. Now the entrance to the pipe is in tank A. That is why we say head loss at the entrance, because when you're moving from a bigger reservoir or a bigger tank to a smaller pipe, there will always be a head loss. So in this case, since it's the beginning of the pipe, we say head loss at the entrance. Similarly, once you get into pipe 1, there will now be friction. So there will now be head loss due to what? Friction in pipe 1. Now, before you enter into pipe 2, there will be head loss due to what? Contraction, because you are moving from bigger to smaller pipe. So head loss due to what? Contraction. Now, when you now enter pipe 2, there will now be head loss due to friction in pipe 2. Now, before you enter pipe 3, there will be head loss due to what? Enlargement, because you're moving from now a smaller pipe having smaller diameter to a bigger pipe with a bigger diameter. So head loss due to enlargement of the pipe. Now you're now moving from pipe 3. When you now enter into pipe 3, there will now be head loss due to friction in pipe 3 altogether. So this is what we have, plus I will have the velocity at pipe 3 square all over what? 2g. So this is what we have there. Is that okay? So we proceed. Like I always tell you, the first thing you have to do in cases like this is for you to write out your parameters, your data given. And the first one here that was given is the diameter of pipe 1, which is 300 millimeter, right? And converting from millimeter to meter, you divide by 1000 and you'll be having 0.3 meter. The second one is diameter of pipe 2, which is 200 millimeter, and that will give me 0.2 when you divide by 1000. So we have 0.2 meter. The third one is the diameter of pipe 3, that is 400 millimeter. Converted to meter, you're dividing by 1000 and you'll be having 0.4 meter. Now the next one is the length. So the first one here is the length of pipe 1, and that will give me 450 meter, followed by the length of pipe 2, which is 255 meter, followed by the length of pipe 3, which is 315 meter. Now the next one is the friction in each pipe. So the friction in pipe 1 is 0.0075. The friction losses in pipe 2 is given as 0.0078, and in pipe 3 is given as 0.0072. Like I always tell you, it is important when you're given diameter, you calculate for the area. Now for A1, for area in pipe 1, we'll be having pi d1 square all over 4. Now when you input your formula, your value in your formula, we know pi is 22/7, 22/7 is 3.142, multiplied by the diameter of pipe 1, which is giving us 0.3, so we have square there, all divided by 4. And 0.3 square is 0.09, multiplied by 3.142, you'll be having 0.2828 divided by 4. And the area at pipe 1 will now give me 0.070695 meter square. So I'm going to put it at my A sub 1. Similarly, for A sub 2, area at pipe 2, still the same thing is happening. Pi d square, pi d2 square over 4. We know the pi is 3.142, multiplied by the d2 here, diameter of the pipe 2 is 0.2. There's a square divided by 4. So A sub 2 here will now give me, when you multiply 0.2 square times 3.142, be having 0.1257 divided by 4. You say your A sub 2 will now give us 0.03142. So I'll put it here. Similarly, we have area at pipe 3, the surface area of pipe 3 will now give us pi d3 square over 4. So we know what the pi is, 3.142 multiplied by d3, which is 0.4, there's a square there, all divided by 4. So my A3 will now give me, when you multiply 3.142 times 0.4 square, you'll be having 0.5027 divided by 4. So the area at section 3 or area at pipe 3 will be equal to what? 0.12568. So I'm going to put it here. So these are all the parameters that we are going to be working with, right? So similarly, from the formula that we have, we need to calculate for the velocity, right? We need the velocity in pipe 1, we need the velocity in pipe 2, and also the velocity in pipe 3, all together. So considering minor losses, right? We're calculating for V1, V2, and V3 in each pipe. We know the discharge in pipe 1 will be equal to discharge in pipe 2 is equal to discharge in pipe 3 because they are in series. So what is discharge? Area times velocity. So that means Q1 give us A1 V1 equals to Q2 will give us A2 V2 equals to Q3 will give us A3 V3, right? So I'm going to term that my equation 1, or we'll say my equation 2. Now from here, what we'll do here is this. We want everything to be in terms of what? Velocity at pipe 1. So we'll say that A1 V1 is equals to what? A2 V2. We'll take this first 2. So if you make V2 of the formula, my area in pipe 1 times velocity in pipe 1 all divided by what? Area in pipe 2. Now we know very well that the area in pipe 1 is 0.070695 multiplied by V1 all over area in pipe 2, which is given as 0.03142, and that will give us, when you divide 0.070695 divided by 0.03142, you'll be having 2.25 V1. Similarly, A1 V1 is equals to what? A3 V3. Now remember, everything should be in terms of what? V1. So my V, if you divide both sides by A3, my V3 will now be equals to A1 V1 all over A3. So what is my A1? 0.070695 multiplied by V1 all divided by 0.12568. That is the area at pipe 3. So from here, we will have, if we divide 0.070695 times V1 all over 0.12568, if we divide them, we're going to be having 0.56 V1. So this is what we have, right? So recall what we have here from our formula from equation 1 above. If you look at it closely, we see that the difference in the liquid surface level is equal to sum of the various head losses in the pipe. So we know very well, if we now write this again, my H will now be equals to my HI, which is the head loss at the entrance. Standard is giving us 0.5 V1 square over 2G, plus we know head loss due to friction is given by 4FLV all over D times 2G. But due to it is at pipe 1, we'll be having 4 times F1 L1 V1 square over D1 times 2G. You know the F1 is the friction, L1 is the length, and V is what? Is the velocity. D is diameter. So move forward, plus the head loss due to contraction, like I explained earlier. So it's still giving us standard 0.5 V2 square over 2G, plus the head loss due to friction at pipe 2. We have 4F2 L2 V2 over D2 times 2G, plus the head loss due to enlargement of the pipe, and we have V2 minus V3 all over what? 2G. So V2 minus V3 all square over 2G, plus head loss due to friction in pipe 3, that'll be 4F3 L3 V3 square all over what? D3 times 2G, plus the velocity V3 square all over what? 2G. So this is the formula when you transform equation 1 into equation 3. So I'll count this my equation 3 here. So like I told you, we'll start For H, the head loss, the capital letter H is given as the difference in liquid surface, which is given as 18 from our question, from our parameters, equals to 0.5 v1 square over 2g, since we don't have velocity, plus you put in all your parameters. 4 times friction at pipe 1 is 0.0075 multiplied by the length at pipe 1, 450, times the velocities at pipe 1 square all over the diameter at pipe 1, 0.3 times 2g. Now, when you now multiply 4 times 0.0075 times 450 divided by 0.3, you are going to be having 45 v1 square over 2g. Then you add it to this. Plus, the same thing happened here. 0.5 times, now my v2 is given to be what? 2.25 v1, as you can see here. So there's a square in the v2, so everything will have square, all over 2g. 2.25 v1 all square means that 2.25 square v1 square, and you now multiply 2.25 square times 0.5, you'll be having 2.53 v1 square all over what? 2g. That is what you'll be having. Then you add it to that one again. So we'll move to the next one on the list, which is 4f2 l2 v2 square all over d2 times 2g. If you start imputing the value that we have here, we are going to be having 4 times 0.0078 times 255 into bracket. My v2 square will be represented by 2.25 v1 all square, all divided by what? 0.2 times 2g. This is what we'll be having there. So the v2, remember, is that's a square, and the v2 is given as 2.25 v1. Start taking. So that is what we have. Now, when you now expand 2.25 v1 all square, it means 2.25 square v1 square. Now, 2.25 square times 255 times 0.0078 times 4 divided by 0.2, that is going to give us 201.39 v1 square over what? Over 2g. We are going to add it to that equation. Then we'll move further to the next one, plus v2, we know v2 is given as 2.25 v1, minus v3, we know v3 is 0.56 v1. Everything has square, all divided by what? 2g. Now, if you look at 2.25 v1 minus 0.56 v1, like terms. So when you subtract them, you're going to be having 1.69 v1. And when you open the bracket, you'll be having 1.69 square and v1 square, your indices. And 1.69 square is going to give us what? 2.86. Then we have v1 square all over 2g. You add it to the rest there. Plus the next one, we have 4 times f3 is given as 0.0072 times l3 is given as 315 times we have v3, which is given as what? 0.56 v1, but the v3 has square, so we have square here. Altogether, all divided by 0.4 times 2g. Now, you look at 0.56 v1 all square, applying your indices, the square will affect the both value inside. So we're having 0.56 square and v1 square. Now when you multiply 0.56 square times 315 times 0.0072 times 4 divided by 0.4, we are going to be having 7.11 v1 square all over what? 2g. So I'm going to add it to that same equation up there. Plus, we have V3 is giving us 0.56 V1, so it has square, all divided by what? 2G. This is what we have. Now, if you now expand this because of the square, you'll be having 0.56 square times V1 square, right? And when you now find the square of 0.56, you're going to be having 0.314 V1 square all over what? 2G. So this is what you're going to add to this equation here, right? So we proceed. All together. So from here, since we're having this, we will now move forward. We'll now say the h here, which is 18, is equals to what is common to everything here? V1 square all over what? 2G is common, so we bring it out. So you now be left with 0.5 plus 45 plus 2.53 plus 201.39 plus 2.86 plus 7.11 plus 0.31. Right? This is all what we have. Now when you add everything together, you now see that 18 is equals to V1 square over 2G in bracket 259.7. Now 18 will now be equals to V1 square divided by, we know that G is 9.81, so 2 times 9.81 will give us what? 19.62. And 259.7 divided by 19.62 is going to give us 13.24 V1 square altogether. So 18 is equal to 13.24 V1 square. Now if you make V1 square out of the formula, it will now become 18 divided by 13.24 is equals to what? V1 square, which is given, and 18 divided by 13.24 will now give us 1.369. And when the square comes to the other side, it becomes square root. So square root of 1.369 will now give us what? 1.166 meter per second. That is my what? My V1. So this is where you are considering what? Minor losses. I will together now. Now the discharge will now be A1 V1. So we know that my A1 is given as 0.070695 multiplied by the V1 we just got here. That is 1.166. So my discharge will now be 0.082 meter cube per seconds altogether. So this is when you are considering minor losses. Now, if you are not considering minor losses here, what will you do? From here, right? What's in the bracket is what we have in my equation 1. This is HI, that is head loss at the entrance. This is HF1, that is friction loss in pipe 1, plus this is HC, head loss due to contraction. The next one is the friction in pipe 2. The next one is head loss due to enlargement. And the next one is friction in pipe 3. Then the last one is what? What we have there from our formula, V3 cube all over 2G. That is what we have there. That is the 5 of them. So if you're not to consider head loss, you're going to remove the head loss at the entrance, the head loss due to contraction, the head loss due to what? Enlargement, right? So if you remove those 3, you'll be left with what? 18, right? Equals to V1 square over 2G in bracket 4.45 plus 201.39 plus 7.11 plus 0.31. I will get altogether. So 18 now will now be equals to V1 square over 2G. When you add all together, you'll be having this to be what? 253.81. Right? So 18 will now be equals to, we know 2G means 2 times 9.81, and that is 19.62. So if we say 253.81 divided by 19.62, you'll be left with 12.94 V1 square. So 18 is equal to 12.94 V1 square. So if you divide both sides by 12.94, 18 all over 12.94 equals to what? V1 square. And when you now divide it, 18 divided by 12.94 will now give us 1.391 equals to V1 square. When the square comes to the other side, it becomes square root of 1.391. So my V1 is equals to what? 1.18. Are we together? So from here, we'll now put that back into our formula. So the discharge Q will now be equals to A1 V1. So in this case, my A1 will know what it is, 0.070695 multiplied by my new V1 here, when you don't consider head loss, is 1.18, right? So when you multiply both of them, you'll now be having what you see on the screen here, 0.0, you can see that. So this is what you're going to be having as our what? As our discharge. So if you're finding this video helpful, please don't forget to like the video, subscribe to the channel, and also what? Share the video. Thanks for watching.